So, welcome to topic 7.11, extinction. Not the most exciting topic as far as um, it's a little bit sad. But extinctions have occurred throughout Earth's history. Extinction is a kind of a natural part of the Earth's process, right? Um, so, from a non-human centric point of view, look back in time here at the bottom of this axis. You have millions of years ago, 542 being the earliest evidence we have, fossil evidence that we can see. And of course, the numbers on the left are the percentages of species that died off during certain times. You have definitely huge spikes where you have much of the Earth, of much of the life on Earth, being exterminated. Most of this is sea life, right? Over here, here's the what used to be called the KT boundary. Now it's the KG boundary or KPG boundary. This is a massive extinction event that kind of gave rise to mammals here and on. Without this extinction event, we could never have existed. Extinction has occurred throughout Earth's history. Extinction rates can be rapid during times of ecological stress, as we're going to see. Extinction rates can vary, right? This is obviously seems to be a very fast extinction event right here, but it could have occurred slowly over a long period of time. Okay, so first we cannot, and I put this very big because it is a very major point. Roughly 1 million species of plants and animals face extinction caused by human environmental impact. Human impact. In other words, we are causing an extinction, and some theorize that we are in the middle of a major extinction event caused by us. Not just climate change, but the burning down of the Amazon, which is occurring right now, the urbanization of areas, and even in rural areas, when you convert land to farming, you're really ruining habitats for a lot of different species. If you think about the coral reef, go ahead and look at what's happening to the coral reef, or it has been happening for quite some time. Read about what's happening to these locations. It's definitely human-caused extinction. Human presence is definitely pushing it along. So, another thing about extinction, the amount of diversity in an ecosystem can be determined by the rate of speciation and the rate of extinction. So, we know that given isolation, different populations will speciate, right? Question is, how often does that happen, and how often are species going extinct? How often are these lines deadening off, right? This will give us a good glimpse of how many species we have. If you remember the diversity index, we measured the number of individuals in the species and put it over the total number of individuals in all species. Well, as you can guess, when you're adding these up, adding up n over n, what's that? Adding up little n over big N, 1 plus little n over big N, 2 plus little n, I should just square these for sure, 3 over big N, right? When you're adding these together and so on and so on, when you start cutting out these terms, you're going to reach a much lower diversity, and you can calculate that for yourself if you want and simulate it. But the point is, the rate of speciation, right, plus the rate of extinction is going to help determine how not only how resilient this ecosystem is to change, but how much diversity you'll find, right? Similar to, if you remember, births minus deaths. You can think of this as birth of species, deaths of species. So it's a similar type of thing there. Okay, extinction provides newly available niches that can be exploited by different species. This is true. You may have heard of something. I don't know if you guys have heard of this, but Cambrian explosion. Cambrian explosion. It occurs really 541 billion years ago over here. This is the Cambrian era. Well, there was a mass extinction before this point. You had this explosion of species, this adaptive radiation, all these different species coming out of this. Every species that we have today, every animal species, every complex multicellular species that we know of, kind of came from this Cambrian explosion. This great dying off that occurred beforehand kind of paved the way by leaving these different niches open. And of course, the exploiting of those different niches by all these different species caused a mass speciation event, which greatly upped the diversity and gave us all the animals that we have today, all the different diversity of species. Everything can be traced back to kind of this event right here, this Cambrian explosion. So in this case, extinction was, quote unquote, a good thing if you think of it from a human perspective, because we could not have existed without this extinction event that occurred here around 541 million years ago, because we could have never had these open niches for all of these species to occupy. Okay, I want to say one last thing about this little frog here. His name is Tuffy. Tuffy, if you Tuffy is this frog's name. Tuffy is now dead. He is the last of his kind, the last of his species. He was a Rab's fringe-limbed tree frog. He was captured captured in Panama. They tried some breeding with him, but his children were not, his offspring were not very, did not survive. His mate died, and he is the last of his species. You'll never see this Rab's fringe-limbed tree frog ever again. Right? It's a dead species. So I just kind of wanted to give you an example of a species that died recently. This was in 2016, just to let you know that, hey, this has a real impact. And look at this little guy; he's kind of cute, right? So just keep that in mind. I also wanted to show you this graph here. This is kind of showing the correlation between humans or Homo sapiens entering a continent and what happens to the mammal population, the large mammal population of continents, as humans enter. And as you might expect, humans kind of dominate the ecosystem, and you'll see a sharp drop in the number of large mammals. Particularly, and if you look at Australia, look at the large mammal population drop. Large mammals in North America, large mammals in Madagascar over here. All these populations just drop precipitously once humans enter the territory, showing that there is somewhat of a correlation between humans entering an ecosystem and the loss of life and diversity. So that's about all I'm going to talk about with extinction. So keep this in mind. Humans do have a major effect. That's the one takeaway I want you to take from this. Humans have a major effect on our environment, and it's a disproportionate effect, and it disproportionately affects other species, and it can cause many species to go extinct. So we need to reverse this if at all possible, so we can save our ecosystem. All right, that's it.